The first sign of leafcutter ants is not always the ants themselves. Sometimes it is movement, a strange green current running across the dark forest floor, as if the jungle has found a way to flow in pieces. Under the heavy Amazon canopy, where the air feels warm enough to breathe like steam, and every fallen leaf is already soft with decay, thousands of small bodies move with astonishing purpose. Each ant carries a fragment of leaf above its head, and from a distance the column looks almost gentle. A procession of green sails drifting through shadow. But closer to the ground, the scene becomes something else entirely. Legs grip the wet soil. Antennae flick through invisible chemical messages. Soldiers stand along the edges of the trail like living blades, their heads oversized, their mandibles open, waiting for the first disturbance. This is not random feeding. It is one of the most complex agricultural systems in the animal kingdom, built not by mammals or birds, but by insects small enough to vanish under your boot. The irony is that the leaves are not their meal. A leafcutter ant may spend its life cutting, carrying, guarding, and processing vegetation, yet the colony is not really eating the forest directly. The leaves are raw material. Underground, in chambers hidden beneath roots and soil, the ants feed those fragments to a fungus garden that they cultivate with extraordinary precision. The fungus is the true crop, and the colony survives by farming it. Workers chew leaves into a damp pulp, plant it into the garden, clean away contamination, and maintain the living crop like an underground field. What looks above ground like destruction is actually supply. Every green fragment moving through the column is being delivered into a system that has been refined by evolution into something almost industrial. The ants are not simply taking from the forest, they are converting the canopy into food through a partnership with another organism, and that partnership is so intimate that neither the ants nor their cultivated fungus can easily exist without the other. A mature colony can contain millions of individuals, and when that many insects begin cutting, the scale changes quickly. A tree that looked untouched at dusk can be stripped by morning, its leaves removed piece by piece by a workforce that never seems to hesitate. Each ant follows the trail through scent rather than sight, and the ground becomes a highway of bodies, leaf fragments, and chemical instructions. Smaller workers ride on some of the carried leaves, not as passengers by accident, but as protection against tiny parasitic flies that may try to attack the carriers. Beneath the surface, the colony is divided into castes and tasks: cutters, carriers, gardeners, cleaners, soldiers, and the queen hidden deep inside, producing the population that keeps the whole structure alive. It is easy to admire the efficiency from a safe distance. It is harder to admire it when your foot comes down across the trail. The reaction begins almost instantly because the trail is not just a route, it is an extension of the colony. Disturb the column, crush the line, or stand too long in its path, and the chemical language changes. Alarm pheromones spread through the workers, and the quiet green river becomes defensive. Soldiers push forward with mandibles built less like mouths and more like cutting tools. Compared with the workers carrying leaves, the soldiers look massive, with broad heads and jaws powerful enough to slice tough plant tissue and break through soft skin. The bite itself can feel deceptively small at first. A sudden pinch, a sharp flash, two tiny red points where the blades close. There is no dramatic venom strike, no instant collapse, no cinematic monster attack. That is what makes it so easy to underestimate. The first bite is just a warning written in miniature. But the danger of leafcutter ants is rarely one bite. It is repetition. A person who steps into a foraging trail does not meet an individual animal making an individual decision. They meet a colony responding as one body. One ant bites, then another, each clamping down with mechanical focus. The punctures gather in clusters around ankles, feet, hands, or any skin pressed into the trail. In the heat and humidity of the Amazon, those tiny openings matter. Skin is the body's wall against a world full of bacteria, fungi, decaying plant matter, and wet soil. Break that wall again and again, even in dots so small they seem harmless, and the forest gains entry. Redness spreads around the marks. The skin warms, swelling rises. What began as a pinprick becomes a map of irritation, and in the wrong conditions, those clustered wounds can become open doors for infection. The mandibles are so effective at closing that humans have noticed them for a long time. In some indigenous and rural traditions, large ants have historically been used as emergency sutures. The ant is allowed to bite across the edges of a cut, locking its jaws into the skin, and the body is then removed so the head remains clamped in place. It is a brutal image, but biologically it makes sense. The same jaw structure that lets a soldier grip and cut with force can also hold tissue together. In the forest, where distance from formal medical care can turn a wound into a serious threat, people have learned to read animal anatomy in practical ways. The ant becomes both danger and tool, a tiny surgeon with no mercy and no intention beyond the pressure of its jaws. For the ants, however, there is no cruelty in the attack. There is only defense. The column must be protected because every leaf fragment is part of the colony's food system, and the colony's survival depends on the fungus garden below. A broken trail means interrupted supply. A predator digging into the nest means disaster. Many animals in the Amazon are interested in ants, larvae, or soft underground brood, from anteaters and armadillos to birds and opportunistic insects. The soldier caste exists because a colony this rich in living biomass cannot remain undefended. Their oversized heads are not exaggerated for display. They are a practical investment in force. In a forest where almost everything eats something else, farming does not make leafcutter ants peaceful. It makes them worth defending. What is most striking is how much of their power comes from cooperation rather than size. A single leafcutter ant is fragile. It can be crushed by a falling twig, swallowed by a frog, or washed away by sudden rain. But the colony behaves like a distributed organism, with millions of bodies acting through chemical signals, division of labor, and shared purpose. The fungus garden is its stomach. The trails are its veins. The soldiers are its teeth. The queen is its reproductive heart, hidden from the dangerous world above. When the colony moves through the forest, it is not just insects crossing the ground. It is a living system extending itself outward to harvest energy from the canopy and carry it underground. That is why leafcutter ants make such a perfect beginning for a story about small wounds that become something worse. They do not need the drama of fangs, claws, or venom glands to leave a mark. Their threat starts almost invisibly, with 2 red dots and a sting of pressure so brief it feels unimportant. But the Amazon is a place where small openings are never meaningless. Heat accelerates swelling. Moisture keeps wounds soft. Soil and decaying vegetation crowd the skin with microbes. The body responds with inflammation, and the forest waits at the edge of every puncture. The ants continue moving whether you notice the pain or not, each green fragment held overhead, each worker returning to the hidden garden below. Above them, the tree loses its leaves piece by piece. Below them, the fungus grows. And on the skin, The smallest bite marks imaginable begin to multiply, redden, and swell. A quiet reminder that in the Amazon, even the tiniest jaws can open the door to something much larger. The green iguana does not enter the scene like a predator. It is not built to terrify at first glance, and that is part of the problem. In the wet heat of the Amazon edge, where branches hang over brown-green water and sunlight breaks through the canopy in heavy gold strips, an iguana can look almost ornamental. It lies stretched along a branch, with its body flattened against the warmth, claws hooked into bark, throat fan hanging loose, eyes half open, as if the entire forest has slowed down around it. Its skin catches the light in greens, greys, and bronze shadows. It does not stalk, it does not snarl. Most of the time it is doing exactly what a large herbivorous lizard should be doing, warming its blood, watching the world carefully, and waiting for the right moment to feed on leaves, flowers, shoots, and fruit. That peaceful image is why people lean too close. But calm is not the same as harmless. The green iguana's mouth is not the soft mouth of a grazing animal. It is lined with rows of small, sharp, serrated teeth, built for slicing plant material with clean efficiency. Tough leaves do not tear themselves, and an animal that eats vegetation still needs tools capable of cutting through fiber. The teeth are not large enough to look dramatic from a distance, but up close they form a fine saw edge along the jaw. What shears through leaves can shear through human skin just as easily. The first bite may not even look serious. A quick snap, a flash of pressure, a couple of neat punctures, maybe a thin line where the teeth drag. It can seem too small to matter, especially from an animal people expected to behave like a living branch. The forest teaches again and again that small openings are never meaningless. Skin is a border, and the Amazon is full of life waiting at every border. On bark, in water, under leaves, inside mud, and across animal skin, bacteria are part of the landscape as much as roots and insects. Iguanas are well known for carrying salmonella bacteria on their skin and in their mouths, and when a bite cuts through the surface, those organisms can be pushed directly into damaged tissue. A wound that begins as a clean mark can become a warm, swelling pocket of trouble within hours. The skin around it reddens, the area grows hot. Pain deepens from a sting into a throb. What looked like a minor injury begins to behave like something alive beneath the surface. The structure of the bite makes that risk worse. Iguana teeth are small, numerous, and sharp, and under the force of a sudden defensive snap, fragments can break off and remain embedded in the wound. This is where the danger stops being visible. The surface may show only a little blood, but below it, a tiny piece of tooth can sit like a splinter of bone-colored contamination, keeping the tissue irritated and giving bacteria a protected place to multiply. In the warm humidity, where sweat softens skin and every step through the forest brings contact with soil, leaves, and water, that hidden fragment can turn a simple cut into a slow problem. The animal is gone, the branch is empty, and the wound is still carrying part of the encounter inside it. To understand the bite, it helps to understand the animal's body. Green iguanas are reptiles, and their lives are shaped by heat. They do not create body warmth the way mammals do. They borrow it from the world. Morning sun is fuel. A warm branch is a charging station. The iguana climbs, turns its body, and adjusts its posture to regulate temperature with a precision that looks lazy only if you are not paying attention. When it is cool, it becomes slower. When it is properly warmed, muscle reaction sharpens. A hand reaching toward an iguana at the wrong moment can discover that the slow animal was not slow at all. It was simply conserving energy until it needed to spend it. Its senses are also tuned for a life of caution. The eyes scan for movement from above, below, and across the branches, because the iguana is not only a browser of leaves, it is prey. Birds of prey, snakes, large mammals, and caimans near the water can all turn a careless iguana into a meal. Even adults must remain alert. That constant pressure explains why defense can appear sudden and intense. A startled iguana does not pause to decide whether the approaching hand is curious, careless, or dangerous. It reacts like an animal that has spent its entire evolutionary history being hunted. First, it may freeze, then lean away, then bolt. If escape is blocked, the mouth opens and the tail becomes a weapon. That tail is not decoration. It is long, muscular, and capable of whipping sideways with enough force to raise painful welts. In breeding season, especially among males, the whole animal becomes more confrontational. Hormones change the risk calculation. Territory, mates, and dominance matter, and a male that might otherwise avoid conflict can stand its ground with head bobs, body inflation, tail lashes, and bites. The same lizard that looked like a calm vegetarian on a branch can suddenly become a green-scaled warning sign. Not because it has become evil or aggressive in a human sense, but because survival and reproduction have narrowed its choices. In that moment, distance is the only respectful decision. There is an almost unfair irony in this animal. People are naturally afraid of fangs, venom, claws, and teeth that announce themselves. The iguana announces almost nothing. It sits in daylight. It eats leaves. Its face does not carry the obvious threat of a predator. That makes the injury psychologically disarming. A person bitten by a snake may react with urgency. A person bitten by an iguana may rinse it quickly, laugh it off, or ignore it until the swelling forces attention. And that delay matters. Bacteria do not need drama. They need time, warmth, moisture, and access. The iguana's bite gives them the access, and the jungle gives them everything else. In the wider ecosystem, the green iguana is not a villain in this story. It is a large herbivore moving energy through the forest, feeding on vegetation, dispersing seeds through its droppings, and providing food for predators at different stages of its life. Young iguanas are vulnerable to birds, snakes, fish, and mammals. Adults are tougher, stronger, and better armored by size and experience, but still part of the food web. Their defensive equipment is the price of being edible in a world that wastes almost nothing. The serrated teeth evolved for plants. The tail evolved for escape and deterrence. The bacteria are not a planned weapon, just part of the living surface of an animal in a microbial world. But when all of it meets human skin, the result can feel designed. That is what makes the green iguana such a strong second step in a story about wounds that begin small and become something worse. It does not fit the usual image of danger. It is not a hunter. It is not venomous. It is not even interested in confrontation most of the time. Yet a single startled bite can leave punctures that swell, redden, and burn with infection, especially if broken teeth remain hidden below the surface. The animal slips back into the branches, claws scraping bark, tail dragging over leaves, its body returning to the heat and green shade. Below, the person looks at two small marks and thinks they have escaped with almost nothing, but the skin is already telling another story. In the Amazon, even a vegetarian can carry a mouth sharp enough to open the body, and the forest is always ready to enter through the smallest door. High above the Amazon floor, where the trees knit together into a living ceiling, Spider monkeys move through a world most animals never truly enter. The ground below is dark, wet, and crowded with roots, insects, and fallen leaves, but the canopy is a different country entirely. It is brighter, more open, and full of gaps that look impossible until a monkey crosses them without hesitation. A long arm reaches, fingers hook around a branch. The body swings forward, light and controlled, and then the tail takes over like a fifth limb, wrapping around wood with enough strength to hold the animal's full weight. For a moment, the monkey hangs suspended in green light, not falling, not climbing, but flowing through the forest as if the branches were a river. Spider monkeys are built for that suspended life. Their limbs are long, their bodies lean, and their prehensile tails are powerful enough to act almost like an extra hand. The underside near the tip is sensitive and textured, giving the tail the grip and feedback needed to hold branches while the animal feeds, balances, or changes direction. This is not just acrobatics for display, it is survival in a three-dimensional forest where fruit appears in scattered patches and food can be separated by wide, empty spaces. A spider monkey does not simply travel through the canopy, it reads it. Every branch has weight, angle, and risk. Every gap must be judged. Every movement is a decision made at speed, far above a forest floor filled with predators that would gladly take advantage of a mistake. Most of the time, spider monkeys are not looking for conflict. They are social, intelligent, and deeply connected to the forest's fruiting cycles. Their days are shaped by searching, feeding, resting, and maintaining contact with others through calls and movement across the canopy. As they feed on ripe fruit, they also become important seed dispersers, carrying the future of trees through their digestive systems and dropping seeds far from the parent plant. In that way, the monkey is not separate from the rainforest's architecture. It helps build the very canopy it depends on. A fruit eaten in one tree can become new growth somewhere else, and the animal swinging overhead is quietly moving the forest forward, one meal at a time. That intelligence and familiarity are exactly what make encounters with humans feel so deceptively safe. A spider monkey can look curious instead of dangerous. Its face is expressive. Its hands seem almost familiar. Its movements have the unsettling closeness of another mind making choices. Around places where monkeys become habituated to people, or worse, conditioned to expect food from human hands, that boundary begins to break down. The wild animal does not become tame. It becomes confident. It learns that people carry objects worth approaching, that bags may contain food, that hands may offer fruit, and that distance is no longer automatic. The danger does not come from a monster in the trees. It comes from an intelligent animal placed too close to human skin. When a spider monkey feels cornered, threatened, or frustrated around food, the bite can be deliberate and serious. A primate bite is different from a scratch or a quick nip from a smaller animal. The canines are long enough to drive deep into the hand or fingers, creating narrow punctures that may look small at the surface, while the real damage continues below. This is what makes the injury so easy to misread. There may be only 2 clean dots, a little blood, and a sharp shock of pain. The skin can even begin closing over the entry points quickly, giving the false impression that the wound is already finished. But beneath that closing surface, the puncture channels may be deep, dirty, and difficult to clean. Hands are especially vulnerable because they are full of small spaces where infection can spread in dangerous ways. Tendons, joints, sheaths, and tight compartments lie close beneath the skin. A bite to the finger does not have much soft tissue to absorb the injury. The teeth can push bacteria into places where washing the surface does very little. Once the puncture seals, the wound can trap contamination in a low oxygen pocket, creating conditions where bacteria can multiply while the outside looks almost calm. That is the cruel trick of a deep primate bite. The body may close the door while the problem is still inside the room. The monkey's mouth carries bacteria like every animal mouth does, but the risk feels more personal because primates are so close to us biologically and behaviorally. The bite is not a random mechanical accident, it feels intentional. The animal grips, pulls and clamps down with an awareness that makes the injury psychologically different from brushing a branch or stepping into insects. A monkey can look at a hand, reach for it, and bite where it chooses. That closeness is what makes the two puncture marks so disturbing. They do not look dramatic at first, but they carry the mark of another intelligent mammal defending space, food, or itself with tools that evolved for feeding, threat, and social conflict. Within a day or two, the wound can begin to reveal what the first glance missed. The skin around the punctures grows hot. Swelling tightens the finger or hand until bending it becomes painful. The area may throb with a deep pressurized ache. Redness spreads outward from the bite, and pus can form as the immune system fights bacteria trapped below the surface. In more serious cases, an abscess develops, a pocket of infection that the body walls off but cannot easily clear. What began as two innocent-looking dots can require the wound to be opened again, cleaned and drained, so the pressure and infection can escape. The small surface mark becomes a doorway into a much larger medical problem. In the forest, that delay matters even more. The Amazon is not a clean room. It is warm, humid, and biologically dense. Sweat runs over the skin, mud splashes from the trail. Leaves brush against the wound, insects land and move on. The environment presses life into every opening. Far from a clinic, with time passing and swelling rising, a bite that seemed manageable can become frighteningly difficult to ignore. Fever may arrive as the body shifts from local injury to wider alarm. The hand, which is normally the tool for everything, climbing, gripping, paddling, working, defending, becomes stiff and unreliable. A small wound in the wrong place can change the whole journey. Yet the spider monkey is not the villain of this scene. It is a wild primate shaped by the pressures of canopy life, social intelligence, competition, and survival. Its teeth are not designed for human injury. They are part of a body that feeds, communicates, threatens, and defends. The real problem often begins when human behavior distorts the boundary between observation and contact. Feeding wild monkeys teaches them to close distance. Habituation removes caution without removing power. A monkey that should be moving through fruiting trees begins approaching hands, bags, boats, and camps. The animal pays a price for that change too, because boldness around people can lead to conflict, capture, injury, or death. The bite is one symptom of a broken distance. That is what makes the spider monkey such a powerful beat in this story. It is not terrifying because it looks alien. It is unsettling because it looks familiar. The same hands that swing through the canopy can grab a wrist. The same intelligence that reads branches and fruiting roots can read opportunity around people. The same mouth that processes forest food can leave narrow punctures that close too quickly and fester quietly beneath the skin. In the green light above the trail, the monkey may vanish back into the canopy within seconds, tail curling around a branch as its body rises out of reach. Below, the person is left staring at two small dots on a finger, almost too small to respect. But the body knows the truth before the mind accepts it. The heat begins, the swelling follows. And deep under the sealed skin, the bite keeps working long after the animal has disappeared into the leaves. At night, the Amazon does not feel empty. It feels occupied by things that have stopped needing daylight. The trunks turn black with moisture, the leaves shine like wet glass, and every branch above the trail becomes part of a darker world suspended just out of reach. In the beam of a headlamp, insects flash for a second and disappear. Frogs call from water trapped in leaves. Something small moves in the canopy and then freezes completely. This is the hour when the Amazon tree boa becomes almost impossible to separate from the forest around it. It can hang across a vine, rest along a branch, or coil in a tangle of leaves with such stillness that the eye passes over it again and again. To a person walking below, it may be nothing more than a shadow in the foliage. To a mouse, lizard, bird, or bat moving through the branches, it is the last mistake in the dark. The Amazon tree boa is not a giant snake, and that is part of what makes its reputation feel so surprising. It is slender, muscular, and built for the vertical maze of the rainforest, not for overpowering large prey on the ground. Its body can loop around branches with quiet control, anchoring itself in positions that would exhaust a mammal. The tail helps grip. The ribs and muscles shift in small, coordinated waves. The snake does not need speed across open ground because its world is made of contact points, bark, vines, leaves, and the passing warmth of animals that move too close. In that world, patience is not laziness, it is hunting technique. The boa may remain motionless for long periods, letting the forest come to it. Its face reveals the real design. Along the lips are heat-sensitive pits, small openings that allow the snake to detect warm-bodied prey even when light is almost gone. In darkness, a mammal or bird does not simply vanish from the boa's senses. It glows as a living signal against the cooler background of leaves and air. This adaptation turns the canopy into a thermal map, and the snake can aim its strike with accuracy that feels unfair to anything relying on ordinary night vision. The same branch that looks empty to a human hand may already be measured by the boa in heat, distance, and movement. When people brush against foliage at night, they enter a sensory world where the snake has the advantage. For prey, the strike is a trap closing from nowhere. For a human, it is usually a defensive explosion from an animal that was touched before it was seen. The Amazon tree boa is famous among keepers and field people for being quick to defend itself, and in the forest that temperament makes sense. A snake hanging exposed in branches cannot afford hesitation if a larger animal grabs it, startles it, or pins it against vegetation. Many snakes try to flee first. This one often coils, opens its mouth, and strikes again and again with startling commitment. It is not trying to eat a human hand, it is trying to make the threat let go. But the body receiving the bite does not care about intention, it only feels the result. For its size, the tree boa carries teeth that seem almost exaggerated. They are long, fine, curved backward, and made for gripping prey before coils can secure it. In an arboreal ambush, a missed grip can mean a meal falls away into the leaves. The teeth solve that problem by acting like hooks. Once they enter flesh, their backward curve resists escape, giving the snake the fraction of a second it needs to hold, reposition, and wrap. Against small animals, this design is efficient. Against human skin, it produces a very different signature, a curved cluster of punctures, often deeper than expected, arranged in an arc where the jaws closed and released. The wound can look strangely neat at first, almost too organized to be serious, but the depth tells another story. A bite from a non-venomous snake is easy to underestimate because people often judge danger by venom alone. If there is no venom, they imagine the event is already over, but teeth do not need venom to create risk. The tree boa's teeth can penetrate deeply, and because they are slender, they may break off inside the wound. A fragment left below the skin becomes a hidden irritant, carrying bacteria into tissue and keeping the injury open from within. The surface may show dots. Beneath those dots, the wound can be messy, contaminated, and difficult to clean properly without care. In a humid rainforest environment where sweat, soil, plant debris, and animal bacteria are everywhere, that matters. The bleeding often begins quickly because the teeth create multiple channels through the skin. Blood wells up in small red beads, then smears across the hand or forearm as the person reacts. The punctures may swell within hours, surrounded by bruising where the jaws struck and the skin pulled against curved teeth. Fingers can stiffen, the hand can throb, the arm may feel tight as inflammation builds around the injury. This is the body doing its work, sending fluid, immune cells, and chemical signals into damaged tissue. In the right conditions, that response helps close the wound. In the wrong conditions, bacteria take advantage of the same warmth and moisture. The danger becomes less about the moment of impact and more about what begins afterward. The snake, meanwhile, returns to stillness. That contrast is what gives the encounter its strange power. 1 second, the branch is just a branch. The next, there is an open mouth, needle teeth, a shock of pain, and a ring of puncture marks. Then the animal is still again, coiled among leaves, as if the forest has swallowed the evidence. Its camouflage is not only color, it is behavior. Amazon tree boas can vary widely in pattern and shade, from browns and grays to brighter oranges and yellows, and whatever the color, their broken outlines work well among branches, leaf stems, shadows, and patches of light. They do not need to disappear perfectly. They only need to be overlooked until distance has already vanished. In the ecosystem, the tree boa is neither monster nor accident. It is one of the canopy's quiet regulators, taking small vertebrates from the branches and helping shape the movements of animals that share that vertical space. Its presence changes how prey use the night. A rodent moving along a branch must balance hunger against exposure. A bird sleeping too low may become reachable. A lizard warmed by the day may cool into vulnerability after sunset. The boa exists in those narrow margins where temperature, darkness, and patience meet. Its body is a solution to a specific problem: how to hunt in a crowded, three-dimensional forest where prey may pass overhead, sideways, or inches away in total darkness. That is why this snake belongs in the middle of a story about small wounds that become serious. It does not bring the obvious terror of a large constrictor or the chemical fear of a venomous viper. It brings something more deceptive: a slender body hidden where hands naturally reach, a mouth full of oversized hooks, and a defensive strike that leaves the skin marked in a precise arc of red dots. At first, the wound may seem manageable, even almost embarrassing, because the animal was small. But the swelling that follows tells the truth. Deep punctures are not small to the body. Broken teeth are not minor if they stay buried. Infection does not care whether the snake was venomous. In the Amazon, danger often arrives without a dramatic shape. Sometimes it hangs quietly from a branch, waits for warmth to pass too close, and leaves behind nothing but bleeding dots that slowly tighten, darken, and swell into something far more serious than the first sting promised. The first warning is not the bite, it is the sound. Across a wide Amazon channel, where the brown water moves slowly between flooded roots and fallen trunks, a sharp chorus breaks through the heat. It is loud, rough, and strangely organized. A burst of whistles, snorts, growls, and barking calls rising from the riverbank. For a moment, the water itself seems to have found a voice. Then, the shapes appear. Long bodies cut through the surface in formation, sleek heads lifting one after another, dark eyes fixed on the disturbance near their territory. To anyone expecting the soft, playful animal seen in wildlife clips, the scene feels wrong almost immediately. These are not harmless river clowns. These are giant otters, and in the Amazon, they have earned a harder name: river wolves. The giant otter is the largest otter on Earth, reaching lengths of around 1.7 meters from nose to tail, and its size alone changes the way the animal should be understood. This is not a small mammal slipping quietly between stones. It is a powerful social predator built for open water, flooded forest, oxbow lakes, and river edges where fish gather in the shadows. Its body is long and muscular, shaped like a living spear. The feet are webbed for speed and control. The tail is thick at the base and flattened enough to help drive the body through the water with strong, sweeping strokes. When a giant otter accelerates, it does not look playful. It looks purposeful, almost military, especially when the whole family group moves at once. That family structure is the heart of its power. Giant otters live and hunt in close groups, often made up of a breeding pair and their offspring from different years. The group travels together, calls together, defends together, and teaches younger members how to survive in one of the most competitive waterways on Earth. Their social life is not decorative, it is a survival system. In Amazon waters, size does not guarantee safety. Caimans patrol the shallows. Anacondas wait near floating vegetation and muddy banks. Jaguars come to the water's edge. Piranhas, stingrays, and countless other animals share the same feeding zones. A single otter would still be capable, but a coordinated family becomes something much harder to intimidate. That is why locals do not compare them to wolves by accident. A giant otter group can harass caimans, challenge rivals, and mob anything that approaches too close to a den, a pup, or a fishing area they consider theirs. Their confidence can seem almost unreasonable until the biology behind it becomes clear. They are fast in water, intelligent, vocal, and highly aware of each other's position. One animal may surface in front of a threat while another appears from the side. Calls pass through the group like signals. Bodies turn, dive, reappear, and tighten the distance. It is not the blind aggression of a startled insect or the reflexive strike of a snake. It is social pressure from animals that understand strength in numbers. Their jaws explain the rest. Giant otters feed heavily on fish, including slippery, struggling prey that must be seized before it escapes into dark water. Their teeth are sharp, their bite is strong, and the muscles of the skull are built for holding, tearing, and crushing. Fish scales, spines, and hard-bodied aquatic prey demand a mouth that can close with authority. In the wild, that bite is a feeding tool. Against human skin, it becomes a serious injury. A defensive bite can drive deep punctures and tearing wounds, especially to hands, arms, or legs near the waterline. Unlike the tiny marks of an insect or the clean arc of snake teeth, an otter bite carries mammalian force behind it. The skin does not just open, it can rip, bruise, bleed heavily, and swell fast. The infection risk comes from two worlds meeting inside the wound. One is the otter's mouth, shaped by a fish-eating life and carrying bacteria from saliva, prey, and the river environment. The other is the Amazon water itself, warm, organic, and loaded with microbial life from mud, decaying vegetation, fish, feces, and flooded soil. When teeth punch deep into tissue, they can carry that contamination below the surface, where cleaning becomes difficult. Blood may wash over the wound at first, but bleeding does not guarantee safety. The punctures can close unevenly, swelling around bacteria trapped inside. Within hours, heat and redness may spread. The pain becomes heavier. The skin tightens. What began as a single defensive bite can quickly become a deep, infected wound far from any clinic. The frightening part is how easily the encounter can begin by accident. Most people who meet giant otters are not hunting them or trying to provoke them. They may be fishing from a small boat, drifting near a riverbank, pulling close to a den without recognizing it, or entering a quiet lake where a family group is raising young. Dens are not just holes in the bank. They are the center of the group's world, connected to resting sites, scent-marked areas, and trails used again and again. A person sees only a shaded bank and a patch of trampled mud. The otters see a boundary. When pups are nearby, that boundary becomes serious. Before an attack, they often warn. They surface, stare, vocalize, and display their presence openly. In many animals, a warning is a chance to leave. With giant otters, it is also a sign that the group has already noticed, assessed, and agreed that something is too close. Their boldness is not recklessness. It is the confidence of animals that survive by refusing to give ground at the wrong moment. In a river where caimans can take careless young and rival groups may challenge access to food, hesitation has a cost. A family that defends together keeps its pups alive. There is a sharp irony in the way humans underestimate them. Otters have faces that trigger affection. Their rounded heads, whiskered muzzles, and social behavior make them easy to label as charming. But the Amazon does not reward cuteness. The same intelligence that makes them fascinating also makes them formidable. The same family loyalty that looks beautiful from a distance becomes dangerous when a boat drifts too close. The same mouth that catches fish with precision can leave punctures that swell and infect with alarming speed. They are not dangerous because they are evil. They are dangerous because they are competent. In the ecosystem, giant otters are important predators, helping shape fish populations and competing with other hunters in the waterways. Their presence signals healthy river systems, but also reminds us that the Amazon's beauty is built on pressure. Every animal here is negotiating territory, food, reproduction, and risk. The giant otter does this in open view, with noise, movement, and social force. It does not vanish like a boa or hide like an insect. It announces itself across the water and expects the message to be understood. That is what makes the giant otter such a powerful late beat in this story. By now, the smallest wounds have already shown their danger. Ant bites, iguana punctures, snake teeth, primate canines, but the river wolf brings a different kind of fear. It is larger, coordinated, emotional in a way viewers instantly recognize, and strong enough to turn a close encounter into a bleeding, contaminated injury within seconds. The family slips back into the channel after the warning, bodies rolling through the brown water, calls fading toward the flooded trees. On the bank, the wound is no longer cute, no longer surprising, and no longer easy to dismiss. It is hot, swollen, and deep, carrying the river inside it. And in the Amazon, once the river gets under the skin, the real danger has only begun. The Amazon River does not always announce its largest predator. Sometimes it hides it in plain sight. At the edge of a slow channel, where the water is the color of tea and mud, floating leaves drift past half-submerged roots. Dragonflies skim the surface, small fish break the film and vanish. Everything seems still enough to trust. But beneath that quiet surface, a heavy body can lie almost completely invisible, folded into the shadow of the bank, nostrils barely above water, eyes fixed toward the place where animals come to drink. The green anaconda does not need to chase across open ground. It waits where the forest must eventually lower its head to the river. This is the heaviest snake in the world, and its power is built for patience. The green anaconda is not shaped like a fast, nervous branch snake. It is thick, muscular, and aquatic, perfectly suited to the flooded edges of the Amazon, where land and water blur together. In water, its weight becomes an advantage rather than a burden. The river supports its body, hides its outline, and lets it move with slow, silent control. A capybara stepping into the shallows, a bird landing too close to the bank, a caiman moving through young reeds, all of them enter a zone where the snake may already be waiting. The danger is not speed over distance. It is the sudden collapse of distance that never seemed to exist. The mouth is the first trap. The anaconda has no venom, but that does not make the bite simple. Its jaws are lined with rows of long, backward-curving teeth, each one angled to hold prey the way a hook holds flesh. These teeth are not meant to cut cleanly and let go. They are meant to anchor. When the snake strikes, the mouth does not leave one neat wound. It leaves sweeping rows of punctures, sometimes dozens of small, dark points pressed into the skin in curved tracks where the upper and lower jaws closed. The marks can look almost patterned, like a violent imprint of the skull itself, but the pattern is misleadingly tidy. Beneath each point is a narrow channel driven deep into tissue. The worst instinct is to pull away. Every tooth is curved backward, and the harder the victim struggles against the bite, the more those hooks drag through the skin. A quick retreat can turn punctures into tears. Flesh opens along the direction of force. Teeth can snap under pressure and remain buried inside the wound, leaving fragments below the surface even after the snake releases. That is where the injury stops being only mechanical and becomes biological. The mouth of a large snake carries bacteria, and the water around the strike is full of mud, rotting vegetation, fish waste, and microscopic life. The bite pushes that world into the body all at once. At first, the wound may be dominated by blood and shock. The rows of punctures bead red, then run together. The skin around them begins to swell as the immune system floods the area with fluid and defensive cells. Bruising spreads where the jaws clamped down and where the victim pulled against the teeth. Within hours, the bite can grow hot, tight, and painful, not because venom is moving through the body, but because the body is responding to deep contamination and torn tissue. Infection loves depth. A shallow scratch can be cleaned. A cluster of narrow punctures, especially with broken teeth inside them, can close at the surface while trouble remains underneath. But the bite is only the opening move. For the anaconda, teeth are not the killing mechanism. They are the anchor that gives the body time to arrive. Once the mouth holds, the coils follow. A heavy loop slides over the prey, then another, each one tightening around the chest or body with frightening efficiency. The old idea that constrictors crush bones is too simple. The real danger is more precise. With every exhale, the coils tighten into the space the lungs have just emptied, making the next breath harder. At the same time, pressure disrupts circulation. interfering with the movement of blood through the body. The prey is not shattered. It is overwhelmed from the inside, breath and blood flow being taken away by living muscle. In the water, this becomes even more dangerous. A struggling animal is already fighting mud, current, panic, and the loss of footing. The anaconda's body can use the river like cover and leverage, rolling, pulling and dragging prey away from the bank. Water fills the mouth and nose. The world turns brown and green. Roots flash past. The surface is suddenly close and unreachable at the same time. For animals that live along the river, this is the price of needing water in a place where water itself can hide a predator. The edge of the Amazon is not a border between safety and danger. It is one of the most dangerous meeting points in the ecosystem. The snake's strategy is energy efficient because it has to be. A body this large cannot afford endless failed chases. It survives by choosing moments carefully, using camouflage, patience, and explosive short-range force. Its eyes and nostrils sit high on the head, allowing it to watch and breathe while most of its mass remains submerged. Its patterned skin breaks apart in the reflections of floating vegetation and shadow. Its muscles store power without movement. The anaconda is not doing nothing when it waits. It is reading the riverbank, holding itself at the edge of action until one mistake brings warm flesh close enough. This is why the green anaconda becomes the ultimate finale for a story about wounds that begin small and become something far worse. The earlier injuries in the forest teach the same lesson in miniature. Tiny dots can swell, teeth can break, bacteria can thrive, and a wound that looks manageable can deepen into crisis. The anaconda takes that pattern and enlarges it to river scale. Here, the bite is not 2 dots or a handful of punctures. It is rows of them. Here, the infection risk does not come from a dry bite alone, but from a mouth and a muddy world forced into the wound together. And here, the injury is not even the main event. It is the first grip before the coils arrive. There is nothing wasteful or evil in the attack. The anaconda is not a monster waiting for drama. It is a predator shaped by one of the richest ecosystems on Earth, where every meal is difficult to catch and every failure costs energy. Its method is brutal because the river demands certainty. Prey can kick, bite, claw, dive, or escape into flooded roots. The snake must hold immediately, hold deeply, and hold long enough for the body to do what the teeth began. Evolution has turned the mouth into a living row of anchors and the body into a tightening machine. After the strike, the river returns to its old silence. Leaves drift again. Insects touch the surface. The muddy bank looks ordinary, almost peaceful. That is the most unsettling part. The largest disaster in the water can begin without a roar, without a warning, without even a clear shape. It begins as a sudden impact from below, a mouth full of hooks and dozens of puncture dots appearing at once across the skin. Then comes swelling, then heat. Then the deep contaminated ache of the river carried into the body. And if the coils follow, the bite is remembered not as the injury itself, but as the moment the Amazon took hold and refused to let go.